Good morning, Year 3. So it's Tuesday the 12th of January and I'm going to talk you through your maths lesson today. So I'm just going to share the screen with you. So today's date, the 12th of the 1st, 2021, and our WALT for today is to order a set of proper fractions with the same denominator. So if you'd like to pause the video and just write the date and WALT into your book. So the last lesson with Mrs. Dyer on Friday, you were ordering 2 fractions with the same denominator. So today's lesson is moving on a little bit because we are going to order a set of proper fractions with the same denominator. But hopefully you can use everything that you learnt with Mrs. Dyer to help you in today's lesson. So as it was Friday and it's Tuesday today, it's been a few days since you had the lesson. So we're just going to go over what you learnt with Mrs. Dyer. So I have got 2 fractions on the board. So if you want to pause the video and just talk to the person next to you, so if you've got someone in your room or you could make some notes in your book, what can you tell me about the 2 fractions on the board? Perhaps you can write the fractions and perhaps you can tell me which one is greater or less than. So hopefully you have had a look at both of the fractions and you can see that this fraction over here is 1/3, 1 out of 3 equal parts. So I'm going to write that fraction now and hopefully you have remembered that we start with the fraction line first. Then we write our denominator. So who remembers what the term denominator means? So our denominator is how many equal parts our whole is divided into. So here, our whole, our circle, has been divided into 1, 2, 3 equal parts. So I've got 1/3, 2/3, 3/3. So 3 equal parts. And then I'm going to write my numerator. So who can remember what the term numerator means? Our numerator is how many equal parts we are interested in. So I have shaded in 1, so I am interested in 1 out of the 3 equal parts. So my numerator is 1. Okay, let's have a look at this fraction over here. So again, I'm going to start with my fraction line. And then I'm going to look at my numerator. So my numerator, 1 equal part, 2 equal parts, 3 equal parts. So my whole has been divided into 1, 2, 3 equal parts. So thirds. And my numerator, how many equal parts am I interested in? So here I've got 2 equal parts. So my numerator is 2. So I've got 1/3 over here, and then I've got 2/3 over here. So hopefully you can tell me which one is greater. So 2/3 is the greater fraction because I am interested in 2 out of 3 equal parts, whereas in this fraction, I am only interested in 1 out of the 3 equal parts. So this fraction is greater. If you imagine it's a nice chocolate cake, I've picked chocolate because that's my favourite, I would rather have 2 out of the 3 equal parts than 1 because I'm going to get more cake, okay? So I am going to show that 2/3 is greater than 1/3 by using my comparing symbol. So this shows that 2/3 is greater than 1/3 and 1/3 is less than 2/3, okay? So review of learning, Colin's got a question that he would like us to have a go at. So on the board, I have got A, B and C. In A, I have got 2/5 is greater than 3/5. B, 4/5 is greater than 3/5. And C, 2/5 is greater than 4/5. Or 4/5 is less than 2/5. So have a little think. You might want to pause the video. Which one is correct? Okay, what I'm going to do here is I'm just going to show you with the bar model because I've actually only got 2/5, 3/5 and 4/5 on the board. In all of those questions, we're just dealing with 3 fractions. So I'm just going to take 2/5 to start with. I have split my whole into 5 equal parts, and I'm interested in 2 out of those 5 equal parts. So I'm just going to very quickly shade in 2. Okay, 3/5. My whole is split into 5 equal parts, 1/5, 2/5, 3/5, 4/5, and 5/5. And I am interested in 3 out of those 5 equal parts. So I'm just going to very quickly shade in 3 out of those 5 equal parts. And then the last fraction, 4/5. My whole is split into 5 equal parts, and I am interested in 4 out of those 5 equal parts. So I'm going to shade in 4 out of 5 equal parts. Okay, hopefully by doing or showing that bar model, you can see which fraction is greater. So we can see that 4/5 is greater than 3/5. Oh, I think we've got that on the board somewhere. 4/5 is greater than 3/5. So B is the correct answer. Let's just check the other two to make sure that they're not correct. 2/5 is greater than 3/5. Let me have a look. 2/5, 3/5. No, definitely not. Because 3/5, I've got 1/5 more. One of those equal parts is shaded more. Okay, let's have a look at this one. 2/5 is greater than 4/5. Let's have a look. No, 2/5 is not greater than 4/5 because 4/5 has 2 extra parts. Okay, so the correct answer is B. And we've just explained that 4/5 is greater than 3/5 because I've got more of my parts shaded, my equal parts shaded, and it's 1/5 more. And if we remember Friday's lesson, hopefully you can remember this generalized statement. When the denominators are the same, so in this case, our denominator is 5, the larger the numerator, the larger the fraction. So when the denominators are the same, the larger the numerator, the larger the fraction. So let's just check that here. Our denominators are the same. The larger the numerator, so 4 is larger, the larger the fraction. So 4/5 is larger, greater than 3/5. Okay, let's just have one last recap. So what do we mean by the denominator? So just pause the video. So the denominator is how many equal parts our whole is divided into. And what did we learn yesterday about ordering fractions with the same denominator? We learned that when the denominators are the same, the larger the numerator, the larger the fraction. Or we could say when the denominators are the same, the smaller the numerator, the smaller the fraction. So in this example here, hopefully you've got your paper and you've got a pencil. Can you write what fraction is being represented in this bar model? Okay, so hopefully you have put your fraction line first. Then we're going to write the denominator. So how many equal parts has our whole been divided into? 1, 2, 3, 4, 5. So we've got fifths again. And then we're going to write our numerator. How many equal parts are we interested in? 1, 2, 3, 4. Okay, what does this sign mean? So this is our comparing symbol, and this means that 4/5 is greater than this side. Okay, so if 4/5 is greater than this fraction, what does this need to be? So just pause the video and see if you can draw a bar model to show what needs to be on this side. If 4/5 is greater than this fraction, what does this fraction need to be? So hopefully you have completed a fraction line and your denominator is 5 because our whole is split into 1, 2, 3, 4, 5 equal parts. Now our numerator has to be less than the numerator over here. So our numerator over here was 4 because our whole is split into 4 equal parts. So what does our numerator need to be this side? So 4/5 is greater than this fraction. So hopefully you've come up with a few different answers that it could be. So it could be 1/5, because 4/5 is greater than 1/5. Or it could be 2/5, because 4/5 are greater than 2/5. Or it could be 3/5, because 4/5 are still greater than 3/5. What can it not be? Well, it can't be 4/5, because if it was 4/5, we would have the equal sign, because they would be equal, they would be the same. And it cannot be 5/5, because that would be our whole, and that would be greater than 4/5. Okay, let's move on to today's learning. So we are comparing not just two fractions today, but a set of fractions. But our fractions will still have the same denominator. So let's just have a look at what we've got on the board. And I want you to think about what you notice as we're working through this example. So let's look at the first one, and we're going to write the fraction together. So my whole is split into how many equal parts? Let's have a look. 1, 2, 3, 4, 5, 6. So my whole is split into 6 equal parts. And I am interested in how many equal parts of the whole. Let's have a look. How many are shaded in? So we've got 1, 2. So I am interested in 2 equal parts of the whole. So this image here represents 2/6. Let's have a look at the next one. So our whole is split into or divided into 1, 2, 3, 4, 5, 6. So our denominator is 6, and we'd expect it to be 6 because our WALT today is all about ordering a set of fractions with the same denominator. So our whole is been divided into 6 equal parts. And I am interested in how many equal parts of the whole. Well, let's have a look how many are shaded in this time. 1, 2, 3, 4. So my numerator is 4. Okay, let's have a look at the last fraction. I expect you can guess what the denominator will be, but let's just check how many equal parts our whole has been divided into. 1, 2, 3, 4, 5, 6. So my denominator is 6. How many equal parts of the whole am I interested in? Let's have a look. 1, 2, 3, 4, 5. Okay, what do you notice about those fractions? Hopefully you notice that they've got the same denominator, so the whole has been divided into the same number of equal parts, and hopefully you've noticed that the numerator is different, so we are interested in a different amount of equal parts. Okay, so we're going to have a think about if we can put any of these symbols into our fractions. So are they equal? No, they're not all the same, are they? Okay, so we can't put equal in there. So let's have a little look. 2/6 is less than 4/6. Okay, so 2/6 is less than 4/6. So I'm going to use the less than sign there. 4/6 are less than 5/6. And I can clearly see that on my model. So again, I'm going to use the less than sign to show that. So we can see that 2/6 are less than 4/6 and 4/6 are less than 5/6. Or we could read it the other way. So 5/6 is our greatest fraction, followed by 4/6 and then 2/6. Okay, let's move on. So let's have a go at putting the fractions in order from smallest to largest. So we're going to have a go. So our denominator is the same. So our whole has been split into 5 equal parts. So I'm going to split my whole now into 5 equal parts. Okay, I do all 3 because we know the denominator is the same in each of those fractions. Okay, so let's have a look at the first fraction, 4/5. So my whole is split or divided into 5 equal parts, and I am interested in 4 out of those 5 equal parts. So I'm going to very quickly shade in 4 out of 5 equal parts. The next fraction is 1/5. So my whole has been divided into 5 equal parts, and I am interested in 1 out of those 5 equal parts. My last fraction, 2/5. My whole has been divided into 5 equal parts, and I am interested in 2 out of those 5 equal parts. Okay, so we need to order them from smallest to largest. So looking at our bar models, our pictorial representations, which is the smallest fraction? Hopefully you can see that it is 1/5. So I'm going to write 1/5 first. I'm just going to do it here. Okay, make sure I'm writing my fraction correctly. If you spot any mistakes, let me know. So I write my denominator, which is 5, my numerator, which is 1. Okay, then I'm going to write the next smallest fraction. So I can see that that would be 2/5. So I'm going to write 2/5 next. I'm going to write my denominator, which is 5, my numerator, which is 2. And then my greatest fraction is 4/5, because I've got more equal parts out of the whole. So again, imagine chocolate bars. I know, chocolate again, but imagine they were chocolate bars, okay? I would want this one because I'd nearly have the whole chocolate bar. I'd have 4 out of the 5 equal parts. But if I only had 1/5, I'd only get 1 square out of 5. Okay, so 4/5 is the greater fraction. I'm going to write that here. So my denominator is 5 and my numerator is 4. Okay, so let's see if we can now explain that. So both the denominators, or all of the denominators, are 5. So 4/5 is the largest fraction because, and we've explained, because I've got more equal parts of my whole. So I've got a larger amount of the fraction. Can I insert my greater or less than signs? I think I could, couldn't I? What would they look like? Maybe have a go or tell somebody in the room. So 1/5 is the smallest fraction. It's less than 2/5. So my comparing symbol would look like this. And then 2/5 is less than 4/5. So I'm going to use my less than sign again. Okay, let's move on. So this time we are looking at ordering quarters. So we're dividing our whole into 4 equal parts. And I've got 3 quarters, 1 quarter and 2 quarters. So if you would like to pause the video now, you could have a go at this in your book. So can you order those fractions from, I'm just going to move myself out of the way, from smallest to largest? And remember what we learnt from Coco. When the denominators are the same, the smaller the numerator, the smaller the fraction. So if we're ordering from smallest to largest, when the denominators are the same, and they are the same in this example, they are quarters, the smaller the numerator, the smaller the fraction. And that's because we have less equal parts of the whole. So have a go at ordering those fractions, show it using the bar model, and extra challenge, try and put your greater than and less than symbols in the correct place. Okay, so I'm going to have a go now. So I think, based on what Coco said, the denominators are the same. So the smaller the numerator, so the smaller numerator is 1, the smaller the fraction. So I think it must be 1 quarter, because that's the smallest numerator, but I'm going to check. So I'm going to divide my whole into 4 equal parts, 1 equal part, 2 equal part, 3 equal parts, and 4 equal parts. And I am interested in 1 of those equal parts, because that's what my numerator tells me. 1 out of 4 equal parts. So I'm going to shade in 1 out of 4 equal parts. Okay, the next one I think will be 2 quarters, because 3, my numerator 3 is greater than 2. So I think the next one's going to be 2 quarters, but I'm going to check. So I'm going to divide my whole into 4 equal parts. And I am interested in 2 out of those 4 equal parts. Oh, looks good so far, doesn't it? That 2 quarters is greater than 1 quarter, and I can clearly see that with my bar model. Okay, let's have a look at the last one just to check. So 3 quarters. So I'm dividing my whole into 4 equal parts, and I am interested in 3 out of those 4. Oh, it's gone a bit dark. We don't want that. I've been sat too long. Let's move. There we go. I have to say, I hate sitting and teaching Crit Clay class. You know how much I move about when I'm teaching, and I can't even stand still. So sitting still is a little bit tricky, and I expect it is for you at home too. So do make sure after the lessons you have a little move about, or you go for a walk or something, just to get a little bit of exercise and move around. Okay, back to this one. So 3/4. So let's just check. 3/4 is greater than 2/4. So they are in the correct order. So I'm now going to put my comparing symbol between them. So they were ordered from smallest to largest. 1/4 is less than 2/4. So I'm going to put my less than sign in. And 2/4 is less than 3/4. So I'm going to put my less than symbol there. Okay, so hopefully you got that correct at home. Right then, I'm going to move on actually to the do it, because I think we've had quite a few examples there, and I know from looking at your work how brilliant you all are at fractions. So I think I'm going to get you to have a go at this one in your books. So to start with, what I'd like you to do is to order the 3 fractions here from smallest to largest. So please make sure that you draw a bar model to prove and to help you see which fraction is the smallest, okay? So make sure you are using that pictorial representation. So I would suggest that you have 8 squares, or you use a ruler and draw 8 centimeters, because the denominator is 8 and that stays the same for today's lesson. So if you split your whole into 8 equal parts, and then show me 7/8, 1/8 and 3/8, and order them from smallest to largest. You can also put that comparing symbol in as well. And then your second challenge for the do it is I have already given you some fractions. So we have got 2/9, and then I've put a comparing symbol in. So you need to be able to read that comparing symbol. Then I've got 5/9. Then I've got 6. Ooh, I've got a missing denominator there. So can you work out, thinking about today's lesson and what we're focusing on, what that denominator would be? And then, oh, I've got my denominator, which is 9, but now I've got a missing numerator. So what could be in there? What could the numerator be? Is there more than one possible answer? And then if you've got time, maybe discuss with the person in the room what it couldn't be and why. Okay, so just pause the video and have a go at those 2 activities. Okay, hopefully you have had a go, and I'm going to go through the answers with you now. So I'm just going to use one bar model to show this, okay? So hopefully you have ordered these 3 fractions from smallest to largest. So based on what Coco said, when ordering fractions with the same denominator, the smaller the numerator, the smaller the fraction, because I've got less equal parts out of my whole. So I think then that 1/8 must be the smallest fraction, because the denominators are the same and 1 is the smallest numerator. So I'm just going to check that. I'm going to split or divide my whole into 8 equal parts. And for 1/8, I am interested in 1 out of those 8 equal parts. So I am going to shade in 1. Now, if I've ordered them correctly, we should, as we show 3/8, have more of those equal parts shaded in. So let's check. 3/8. So my whole is split into 8 equal parts. 1/8, 2/8, 3, 4, 5, 6, 7, 8/8, which is the same as a whole. And this time my numerator is 3. So I'm hoping, if I've ordered them correctly, that 3/8 is going to be greater than 1/8. So I'm going to have more of my equal parts shaded in. So 1, 2, 3. So 3/8 is greater than 1/8. And then I think the next fraction has got to be 7/8. So let's just check. 1, 2, 3, 4, 5, 6, 7. So 7/8 is greater than 1/8 and 3/8. So I'm just going to write that here. So if we're ordering them from smallest to largest, 1/8 was my smallest, followed by 3/8, followed by 7/8. And if you've put the comparing symbol in, then hopefully you've shown that 1/8 is less than 3/8 and 3/8 is less than 7/8. Okay, in the example here then, we were looking for a missing denominator and a missing numerator. So hopefully here, you put the denominator 9 because you noticed that the other denominators were 9, and our walk for today was to order a set of fractions with the same denominator. And that works, doesn't it? 6/9 is greater than 5/9. Okay, because we've got more equal parts out of the whole there. We've got 6 instead of 5. So then what could this be? Our denominator is 9 still. So I'm looking for a numerator that is greater than 6. So something ninths is greater than 6/9. So what could it be? So hopefully you've put that it could be 7/9, but it could also be 8/9, and it could also be 9/9. We could go on, but then we wouldn't be focusing on proper fractions, okay? So hopefully you've got one of those 3 answers. What could it not be? Well, it couldn't be anything less than 6/9. So it couldn't be 6/9 or less. Okay, if you need a little bit more practice at ordering a set of fractions with the same denominator, then you will find that you've got some extra do it questions on your maths sheet for today. You don't have to do those do it questions if you're confident, you're secure in what we've learned so far. You can go straight on to the go deep. Okay, so it's up to you. Have a discussion with your parents, see how you feel and what you would like to do. So you'll go deep and go deeper today. Your go deep is all about reasoning, okay? So this is really to check that you're secure in what you've just been taught. So this is where we're looking for you to use some language and to unpick maybe what mistakes have been made. So the go deep today says, Colin thinks that he has ordered the fractions correctly from smallest to largest. Do you agree? Show using the bar model. So hopefully you can see straight away that Colin is incorrect. He has not ordered those fractions from smallest to largest. So what you've got to do in your book is to show the correct order. That's your do it, isn't it? You're doing it for Colin. You're showing the correct order using a bar model. Then hopefully you can notice what Colin has done wrong. If he hasn't ordered them from smallest to largest, what has he done? And can you give Colin a tip to help him understand how to order fractions with the same denominator? And that top tip might be that generalized statement that Coco gave us in the last lesson that you did with Mrs. Dyer and in this lesson. So if the denominators are the same, what could you say to help Colin? Okay, think about that generalized statement. And then you'll go deeper. Always, sometimes, never true. The larger the numerator, the smaller the fraction. Now with the go deeper activity, this is really stretching your thinking. This should be something that you work on independently. If you feel after you've done the go deep that actually you want to leave the go deeper, that's fine. We don't expect everybody to necessarily answer that go deeper, but if you want to challenge yourself and have a go, that would be brilliant, okay? So if you want to pause and have a go at those activities now, and then afterwards I will just go through the go deeper for those of you that have had a go. Okay, so the go deeper was a little bit tricky today, so I just wanted to go over it quickly with you, because although we give feedback on Class Dojo, it can be quite hard to explain things over there and on there in the feedback. So I just thought I'd go over it quickly now. So the go deeper was always, sometimes, never true. The larger the numerator, the smaller the fraction. Well, hopefully you can give an example today where that is definitely not true. Okay, so the larger the numerator, the smaller the fraction. So I've just given an example that we looked at today. So 4/5, we know, is greater than 1/5 because the denominators are the same. So the larger the numerator, the larger the fraction. So the larger the numerator is 4, is larger than 1, the smaller the fraction. But that's definitely not true in this example, okay? So we know that we can give examples where that statement is not true. However, are there some fractions where it could be true? Okay, so this is testing your thinking a little bit. So I've given an example here. I've got 1/2 and I've got 4/10. Now 1/2 is greater than 4/10. So the larger the numerator, so 4, the smaller the fraction. That's true in this example. 4/10 is smaller than 1/2. Okay, so the answer is sometimes. It depends on the fraction that you are looking at. And there is a site that you can look at to explore that in a little bit more detail if you want to, okay? So if that's something you want to look at, this is the site here that you can go on, and even if you just type into Google a fraction war, that will show you that sometimes the larger the numerator, the smaller the fraction, just like in this example here. And I could do a bar model to show you that. So I'll just do that quickly. So if I've got, I keep doing a circle, don't I? Silly Mrs. Barnes, let's go back, okay. So I'm going to split my whole into 10 equal parts. Let's use this one instead. 1, 2, 3 equal parts, 4 equal parts, 5 equal parts, 6 equal parts, 7 equal parts, 8 equal parts, 9 equal parts, and 10 equal parts. And in 4/10, I am interested in 4 out of those 10 equal parts. Okay, I'm now going to do another whole. So wholes need to be the same. And this time I'm splitting my whole into 2 equal parts. So I've got 10. If I'm dividing 10 into 2, then I'm going to have 5 in each of my equal parts. 1, 2, 3, 4, 5. There we go. So I've split my whole into 2 equal parts. And I'm interested in 1 out of those 2 equal parts. So I'm going to shade in 1 out of 2 equal parts. And hopefully you can see now that 1/2 is more than 4/10. So although the numerator is larger in 4/10, the fraction is smaller because I've got less of my whole. Whereas 1/2, I've got more of my whole. Okay, so that's just an example to prove that it's sometimes true. It depends on what fractions you're looking at. And hopefully you stretched yourself and explored that and came up with some examples yourself. Okay, I hope you enjoyed today's maths lesson, and I'm looking forward to seeing all your work later. Have a good day.